Hello dear students. Today's class let us solve a problem to find material change and one more problem to find velocity and acceleration in material form. Let us read the problem 1. At a point x in the current configuration of a certain physical quantity phi associated with the motion is given by phi equal to 1 by r e power minus at 1 by r e power minus at. Okay, r not equal to 0 and r is equal to modulus of x, and a is a constant, positive constant, and also the velocity is given as the first component v1 is x1 x2 into t, okay, and v2 is x2 square into t, then v3 is x2 x3 3. The question is we have to find the material change in phi at some point 0 a comma 0. Our a is a positive constant, so that's a problem. So they have given a motion of a continuum. Continuum is nothing but a physical object which is moving, fine, and there is a physical quantity phi associated with the motion. They have defined it as phi equal to 1 by r e power minus at. A is a positive constant and r is modulus of x. Modulus of x is nothing but square root of x1 square plus x2 square plus x3 square, modulus of that, right? Okay, in that vector x. And also they have given the velocity field and we have to find the material change in phi, okay, at some given point, prescribed point. Now, what is the formula for the material change in phi? Material change in phi is nothing but d phi by dt equal to dou phi by dou t plus q dot del phi. That's a formula, right? We'll call it as equation 1. We have to find d phi by dt at the prescribed point 0 a comma 0, right? Okay. Now, they have given phi, no? Let us write phi. What is phi? See, phi equal to 1 by r e power minus at. Fine, that is our phi. And what is r? R is modulus of x. That means what? That is nothing but modulus of the x vector. X vector is nothing but x1 I plus x2 j and x3 k. That is equal to square root of, what do you mean by modulus of any vector? The square root of the first component square plus the second component square and the third component square. Fine, that is our r. So substituting for r in phi, phi will be equal to e power minus at divided by that r is substituted. R is substituted. Now let us find what is gradient phi. We have to find gradient phi. Remember, we have to use the formula, we have to use this formula 1, right? We have to use this formula 1. In the formula 1, we have this q dot gradient phi. So let us find what is gradient phi. So the next step, I need gradient phi. And we know gradient phi formula is dou phi by dou x1 I plus dou phi by dou x2 j plus dou phi by dou x3 k. So now we have to differentiate phi with respect to x1, with respect to x2 and with respect to x3 and substitute in their respective places, right? So phi is this. We have to differentiate with respect to x1. Now, what is differentiation with respect to x1? With respect to x1, differentiation is nothing but, so we can write this as, that is equal to, so e power minus at as it is. The denominator is there, no? So we can write the denominator as x1 square plus x2 square plus x3 square whole to the power minus half. Correct? Minus half and e power minus 80 as it is. Fine. Now differentiation of this with respect to x1. So what is dou phi by dou x1? So dou phi by dou x1 is nothing but, so e power minus 80 as it is, because that is completely function of t. The remaining we have to differentiate. So we have the power, right? So power is, so minus half, this is into here, minus half, whatever that is. So x1 square plus x2 square plus x3 square whole to the power minus half, okay, minus 1 differentiation, right? Into differentiation with respect to what? X1, no? So with respect to x1, x1 is here. So it is into 2x1. Differentiation of x1 square is 2x1. x2 is constant, x3 is also constant, right? So 2 will get cancelled. What is that we are going to get? That is equal to, minus will be there, okay? Then we have e power minus 80, right? Divided by x1 square plus x2 square plus x3 square whole to the power minus 3 by 2. So we have taken to the denominator, no? So it will become plus 3 by 2. Plus 3 by 2. That plus we will not write. 3 by 2. And x1 as it is. That x1 can be written here. X1 as it is. This is dou phi by dou x1. Similarly, dou phi by dou x2 and dou phi by dou x3. Right? So, we have done that here. See, dou phi by dou x1 is nothing but, dou phi by dou x1 is nothing but, see, minus x1 e power, sorry, let me take highlighter. Yeah. So, x1 e power minus 80 and denominator is x1 square plus x2 square plus x3 square whole to the power 3 by 2. Similarly, dou phi by dou x2 will be x2 there. And dou phi by dou x3 will be x3 over there. Okay, so dou phi gradient phi will be equal to, now substituting all these things, right? So minus is common, so we'll take minus is common everywhere. And what else is common? We have e power minus 80 common and denominator also common. What is remaining here? Remaining is x1i plus x2j plus x3k. This is our gradient phi. So we have found gradient phi, no? Okay. Now let us take, or let us consider this q dot del phi. So gradient phi we have already done, right? And q. And q they have given, this is v1, v2 and v3. So v1i, v2j, v3k, that's nothing but q. This is nothing but for q. And dot, so there should be a dot here. There should be a dot. So let me put the dot there. So there should be a dot here, right? So minus e power a minus 80, the remaining gradient phi we just found, no? That we can substitute. Fine, that is gone there, it's not appearing properly. Now take the dot product. Now this whole thing is common, we can write it outside here, right? So minus e power minus 80 by x1 square plus x2 square plus x3 square to the power 3 by 2 outside. Okay, and then the remaining, the dot product we are taking. So for the first vector x1 into x3 into x1, that is x1 square x2 into t. Okay, so I dot I is gone, so it's 1 there. And similarly for the second vector, no, we have here x2 square and there it is x2. So x2 square into x2 is x3 cube, t as it is, plus third part here x2 x3 t and there will be x3 here. So multiply. So you're going to get x3 square x2 t as it is. Fine. So therefore, the q dot gradient phi is this whole thing. Now what is dou phi by dou t? Dou phi by dou t we have already found, that is this. So what is d phi by dt now? Use substituting in 1. So using these two in 1. So we get d phi by dt, the material change in phi, equal to at the point 0, a, 0. That means what? x1 is 0, x2 is a, and x3 is 0. So substituting that, what are we going to get? So just using, x1 is 0. Okay, x1 is 0. That means this part is gone. This part is gone. Then we have x2 is a, x3 is 0. That is, this part is also gone. That is also 0. Right? And the denominator, this part is 0. And, this is 0. Okay. So what is remaining? We have to write. Substitute and write. So dou phi by dou t, this part is dou phi by dou t. So x1 is 0 and x3 is 0. And what is our x2? x2 is a. Here there is a. So x2 is a. So a square root is nothing but a only. Right? And numerator is minus a e power minus at as it is. Okay. Then plus q dot del phi. So in the q dot del phi, you have a minus sign. You have a minus sign here. So minus will come. So minus the remaining. So e power minus at as it is. Okay. And x2 is a. So it is a cube t. So a cube t as it is. And denominator you have, this is a square. A square to the power 3 by 2. So square and square root will go. You're going to get a cube. Okay. Now taking common factor and simplifying. So d phi by dt at a 0 a comma 0 is nothing but this. As simple as that. Okay guys, so one problem is over on finding the material change of any quantity that is associated with the motion of the continuum. Now we shall go to one more problem. The problem is this. Let us understand and read the problem. So it says that for a certain motion of a continuum, they have given the velocity vector is this. V equal to x by 1 plus t. V is equal to x by 1 plus t. And x is x1, x2, x3. ST means show that the x is equal to x naught, right, into 1 plus t, and also find velocity and acceleration in material form. Okay, yes. So we have read the problem. Okay, yes, let us write what is given. So in the solution, let us write what is given. So given V is equal to x by 1 plus t. Okay, so what is V1? V1 is x1 by 1 plus t. V2 is x2 by 1 plus t. And V3 is x3 by 1 plus t. Correct components. Then, now, first let us prove x equal to x naught into 1 plus t. Okay, okay. So let us take V1. V1 equal to x1 by 1 plus t. Let us consider the first component of the velocity. So V1 is equal to x1 by 1 plus t. What is our V1? V1 is nothing but dou x1 by dou t. What is fixed? Xi not fixed. That is equal to RHS as it is. Now, the next step, remember our Xi naught is fixed. Okay. So let us separating the variables. Dou x1 by x1, dou t by 1 plus t. Integrating this. So LHS integration log x1 and RHS integration is log 1 plus t. Right. We should accommodate integration constant. Right. That integration constant is this f of xk naught. Remember, our xi naught is fixed. So xk naught is fixed, right? So any function of xk naught is also fixed, constant, right? And why we have taken log here? Because we have log here and here. Fine? Okay. Now take away log. So x1 equal to 1 plus t into the function f of xk naught. We have to find what is f of xk naught. How do you find f of xk naught? Take the initial condition. When t equal to 0, we know that x1 equal to x1 naught. Why I am taking only x1 here? Because I have x1. Okay, now substituting these two in the above relation, we get x1. x1 is nothing but x1 naught equal to t is 0, no? T is 0. So f of xk naught. So f of xk naught is nothing but x1 naught. So using that, we get x1 equal to 1 plus t x1 naught. Similarly, the same way, take the second component, right? We are going to get x2 equal to 1 plus t x2 naught. Similarly, x3 is equal to 1 plus t x3 naught. As simple as that. So therefore, x equal to x naught, 1 plus t is common throughout. See, you have x1 naught, x2 naught, x3 naught. In the vector form, it is nothing but x naught vector into 1 plus t as it is. This is the motion in the material form. So we have obtained the motion in the material form? No. Once we have the motion in the material form, it is very easy to find the velocity in the material form. So Vi is equal to dou xi by dou t. What is fixed? Xi naught is fixed. Okay, so take x1 equal to 1 plus t x1 naught. So what is V1? V1 is dou x1 by dou t. What is fixed? Xi naught is fixed. So differentiate this with respect to t with xi not fixed. What is the only not here? It is x1 naught. So this is fixed here. This is fixed here. X1 naught is fixed. So differentiate this. Fixed means what? It's a constant. So x1 naught as it is, and differentiation of this 1 plus t is nothing but 1. So it is nothing but x1 naught. V1 is x1 naught. Similarly, V2, this dou x2 by dou t, xi naught fixed. So x2, no. So that is nothing but x2 naught. Similarly, V3 is x3 naught. So x1 naught, x2 naught, x3 naught. V1, V2, V3, they represent the components of velocity in the material form. Now, we have to find the acceleration in material form. So to get the acceleration in the material. So take Vi's, differentiate with respect to t with xi naughts constants, or by fixing xi naught constants. So A1 is nothing but dou V1 by dou t, xi naught fixed. So what is our V1? V1 is x1 naught. So differentiation of x1 naught is x1 naught with respect to t, and x1 naught is constant. So that's nothing but 0. A1 is 0. A2, that means what? Differentiation of V2 with respect to t, xi naught fixed. Right? So V2 is here. This is V2. This is V2. So differentiation of this with respect to t with x2 naught treated as constant. So that is also 0. Similarly, A3, differentiation of V3 with respect to t with xi naught fixed. So V3 is nothing but, here we have, it is nothing but x3 naught. Nothing but x3 naught. So differentiation of this with respect to t with x3 naught treating as constant. So that is also 0. So A1 is 0, A2 is 0, and A3 is 0. These are the components of acceleration in the material form. Right. Hence, the solution of the problem.